Hello everyone. In our past few videos, we've been seeing that trigonometric ratios are interrelated, and this is one more video of those kinds. So consider a right angle triangle, and let's call it ABC. Let's call this right angle triangle ABC. It's right angled at B, and let's consider that this is angle C is theta. Now, what do we know about this right triangle? In any triangle, the three angles, the sum of the three angles would be equal to 180 degrees. So, this being a right angle triangle, now we already know that angle B is 90 degrees. So, what do we know about angle A and angle C? The sum of those two angles would be equal to 90 because already angle B has taken 190 degrees. So what is left, 180 minus 90 is 90 degrees. So angle A plus C is 90. So if we mark angle C to be theta, then angle A would be equal to 90 minus theta, right? So using this, we are going to arrive at some relationship between trigonometric ratios. So first of all, as usual, let's start with sine of theta. Now what is sine theta? According to this triangle, it is equal to the opposite by the hypotenuse. So if I write it as the length AB by AC. Now, what is the opposite for theta would be the adjacent for 90 minus theta, isn't it? So, what would be sine of if I call this as the opposite by hypotenuse, the one which is opposite for theta would be the adjacent for 90 minus theta. So, what would cos of 90 minus theta be equal to? It would be equal to its adjacent by hypotenuse, but the adjacent of 90 minus theta, as I said, is the opposite of theta. So this is also equal to AB by AC. So we have arrived at one relationship, that sine theta is equal to cos of 90 minus theta. So similarly, let's now this time start with cos of theta. So what do we have? Cos of theta would be adjacent by hypotenuse, as by definition would be BC by AC, and the adjacent of theta would be the opposite of 90 minus theta, isn't it? So it would be the opposite by hypotenuse of 90 minus theta. And what defines opposite by hypotenuse? It would be sine of 90 minus theta, right? So BC is the opposite of 90 minus theta. So cos theta would be sine of 90 minus theta. So this is our second relationship. Cos theta would be sine of 90 minus theta. And these are what we call as trigonometric ratios of complementary angles. These two are complementary angles. 90 minus theta and theta are complementary angles because they add up to 90 degrees. We call them as complementary angles. So similarly, we can establish same kind of relationship for other trigonometric ratios. Let me draw a fresh triangle, and let's call this also as ABC. It's right angled here, and angle C is theta. So we've already seen that sine theta is equal to cos of 90 minus theta, and cos theta is equal to sine of 90 minus theta. Now we can derive the same thing for tan theta and the cosecant theta. So let's do for tan theta first. Tan theta, as we know, is opposite by adjacent, or if this is theta, tan theta is equal to AB by BC, isn't it? Yeah, tan theta is AB by BC. And what is the opposite for theta would be the adjacent for 90 minus theta. So the same AB by BC would hold good for cot of 90 minus theta. If you are not very certain with this, just try doing what is cot 90 minus theta separately. Cot 90 minus theta would be equal to adjacent of 90 minus theta by opposite of 90 minus theta. And what is the adjacent of 90 minus theta? It's AB by BC, and hence both are sin. Right? So we have established a third relationship here, that tan theta, it's equal to cot of 90 minus theta. And I think the same thing can be done for secant and cosecant theta. You can just try it on your own. Let me write down the relationship. Secant theta would be equal to cosecant of 90 minus theta, and similarly cosecant theta would be equal to secant of 90 minus theta, because here we have found already that tan theta is equal to cot 90 minus theta, and of course cot theta, this also holds good, isn't it? Cot theta would be equal to adjacent by opposite. What is cot theta? Cot of theta is adjacent, BC by opposite AB, which would be equal to tan of 90 minus theta. So we have arrived at all the trigonometric ratios for complementary angles, and we have seen what the relationship is between them, and this would come in handy to tackle some problems for us. Thank you.